the east coast of Greenland, the west coast of Iceland, and across northern Spain, where, as Joy said, they'll experience an eclipse within an hour of sunset, so they should have lots of opportunities for really beautiful photographs. And then as the eclipse progresses and that umbra disappears, West Africa will also get an opportunity to see a partial eclipse as that penumbra shadow sort of slides off the edge of the Earth here. Now, as we zoom up and look at Iceland and Spain, Reykjavik is here in that southwest corner of Iceland. We're kind of crossing our fingers for them because it's a little bit cloudy there right now. That umbra shadow is traveling over 2,000 miles an hour as it passes through the path and crosses the North Atlantic. And then it runs into Spain here, where we expect more than 15 million people will be watching this eclipse. Some of them on the beach in Mallorca right before sunset, so they should get some really beautiful photographs over the mountains to the west. Now, the situation in the US is going to look like this. That yellow line is the southern limit of the partial eclipse. So folks south of that line, you're not going to see an eclipse today. But if you're north and east of that line, you may already be starting to see the partial eclipse. It takes 2.5 hours for that partial shadow to pass all the way across the United States. So it's not like totality. You don't have to run out there at the exact moment. Some places will have a partial eclipse that lasts for almost 2.5 hours. Others, maybe just an hour. So this is the situation right now. Montana, your eclipse is over. The shadow is passing out of North Dakota, but Minnesota, Wisconsin, Michigan, you're in it. The Northeast is also in it. And for folks in the Mid-Atlantic, you will be in it soon enough. Now, before you run outside to look at your eclipse that's happening right now, we want to show you a short video about how to observe this eclipse safely.
If you'd like to find and explore the animated eclipse maps yourself, like the ones Ernie was referencing, safety instructions, and much more about today's eclipse, head to science.nasa.gov/eclipses. So next, I'd like to introduce our first guest here in the studio. We have Dr. Kelly Corrick, who is one of NASA's heliophysicists, who studies the sun and its effects across the solar system. And she's also studied the sun's corona in great depth. Thank you so much for helping us kick off today's coverage.
It's great to be here, Joy.
So let's talk about why we don't always see eclipses on Earth. We've got this awesome model here called an Ori. So using this, can we talk about their orbits and why we don't see it every month?
Yes, so here we have the sun, the moon, and the earth. And as we move, we can see that the moon is not exactly on the same line that we have with the sun. So the earth can view the sun pretty well, but when we get it to about here, we can see that sometimes, maybe a little further, sometimes it lines up perfectly so that we're able to have that eclipse. And that's when we have that eclipse. So that 5 degrees off ends up not having eclipse every new moon.
Okay. And so today's eclipse will travel across Europe for the first time since 1999. Yeah. Can you tell me, why does that region not experience eclipses as often? And what is it that makes this eclipse unique?
Right, so this eclipse is unique because of the fact that, A, it's near sunset. It's also the fact that Europe doesn't get as many, just simply as to the location, and any place on Earth, really, it's about 300 to 400 years between the time you get eclipses. So there's a lot of ocean on the Earth that it just doesn't go over land. Plus, with the angle, it tends to move very quickly and pass in and out, so they don't get a lot of eclipses. And again, it's super special being near sunset, so being able to see a sun setting being eclipsed, it's going to be really awesome photos.
Okay. And I've also heard of eclipse seasons. Can you talk a bit about that?
Yeah, so an eclipse season, when an eclipse happens like this, that lineup means that you're going to see the solar eclipse, so either a partial, annular, or total, and then you're going to see a lunar eclipse about 2 weeks later. So in about 2 weeks, we'll be able to enjoy the orientation where the Earth is actually casting the shadow on the moon and having a lunar eclipse. So that's the eclipse season.
Oh, fantastic. And I know Europe is going to have another eclipse happening in 2027, which seems to be a lucky few years for that region.
Yeah, definitely lucky, and it's going to be a wonderful eclipse, and actually the longest eclipse of the century. So it's going to be 6 minutes and 28 seconds. So that's a very long one. Great for scientific investigation.
Wow. And so eclipses can occur somewhere on Earth roughly every 18 months or so?
Yes.
So why is it that NASA continues to study solar eclipses?
Because every eclipse is a little bit different. The sun changes as it rotates changes its 11-year cycle. The Earth and the area of the Earth that it covers is different. So we make sure that we study it each time.
Fantastic. Thank you so much, Kelly.
Thank you, Jill.
So throughout today's coverage, we'll be joined by other NASA experts like Dr. Kelly Corrick, who can answer any of your questions that you have about solar eclipses, the science we're doing, and all the other activities you're hearing about today. You can ask your questions in the chat on YouTube, Facebook, Twitch, and Instagram, or tag @NASA wherever you're watching. We also have questions we want to ask you today. So if you want to head over to NASA's Twitch or Instagram stories and take a look at the poll we've got for you, you can participate and answer those questions. And so before we go on, I just want to point out that you may have noticed a clock counting down in the upper left corner of today's show. We'll have 2 different countdown clocks displayed over the course of the next hour that will let you know how close we are to the first instances of totality in the telescope views we have in Iceland and Spain, respectively. Those are the 2 locations where we hope our telescope partners will be able to capture the best views of the sun being totally eclipsed by the moon. We're tracking totality in Reykjavik, Iceland at 1:48 p.m. Eastern Time, or 5:48 p.m. local time, and that will last about a minute or so. And then we're going to set our sights to Leon, Spain, for totality there at 2:28 p.m. Eastern Time, or 8:28 p.m. local time. And the eclipse there will be about 2 minutes long. So there's a lot of science taking place during those fleeting moments of totality today in Iceland, and we have experiments on the ground and in the air. And in the view looking at right now, there's a camera that will be capturing the view of the sun's corona when it's time for totality. When totality hits in Iceland, the planes are going to be chasing the moon's shadow for as long as they can. They're going to be studying the sun's corona, where the skies will hopefully be clear up there. The plane took off from Keflavik Airport about an hour ago, and then we're going to be talking to the science team live from Iceland very shortly. Before we do that, let's learn more about what it's like to be a NASA pilot in those eclipse experiments.
For most people, a total solar eclipse lasts just a few minutes. But NASA's pilots find a way to make it last longer by trying to outrun the moon's shadow with an airplane.
The truth is, it's actually chasing us. We get out in front of it and let it overtake us. Once we're in totality, then we'll advance the throttles to max and try and stay in totality for as long as we can.
Making that happen takes extreme precision. Scientists calculate exactly where the airplane needs to be at each moment.
We do a lot of missions where being in the right point in time and space are critical, and this is one of them.
On eclipse day, the WB-57 aircraft climbs more than 50,000 feet into the stratosphere. That's above most of Earth's atmosphere, where clouds, dust, and water vapor could obscure the view.
Viewing an eclipse from 50,000 feet provides a really clear shot of the sun. And that allows the scientists to have confidence that the data that they're seeing is from the sun rather than distortions from the atmosphere.
When the moon's shadow arrives, it engulfs the aircraft.
It's weird. Right where you're at, it's dark, but everywhere you see, it's twilight. And the temperature in the cockpit drops, so it's very noticeable.
As the eclipse unfolds, the pilot keeps the aircraft on course, while the sensor operator fine-tunes the cameras, capturing every second of data.
You're very, very, very busy, and it's very high pressure because, of course, there's no do-overs. You only get one opportunity to get all these instruments trained on the right spot.
For the aircraft crew, it's a chance to witness one of nature's most spectacular events while helping scientists better understand our sun.
I'm sitting in the best seat in the house. It's pretty exciting.
Wow, what a job they have today. For this eclipse, the WB-57 aircraft has a camera on the nose of the plane that will be capturing images of the sun's corona. To learn more, let's chat with Principal Investigator Amir Caspi, who is chatting with us live from Keflavik Airport in Iceland. Hi, Amir. Thank you so much for joining us today.
Hi, Joy. It's a pleasure.
So firstly, how are you feeling right now? And can you tell us what experiment you're doing today?
Yes, well, feelings are mixed today because, as you can see behind me, the sky is not very great for those of us here on the ground. On the other hand, we have an airplane that's now cruising at 50,000 feet above sea level that's preparing to observe the eclipse in just about 14 minutes. And we're going to be imaging the solar corona with an instrument that has 4 cameras on board with observations ranging from visible light through near infrared all the way to the mid-wave infrared, which we often refer to as the thermal infrared, to make new observations of the corona and learn all about coronal structure and dynamics.
What is it about the corona, the sun's outer atmosphere, that we're still trying to better understand?
Well, you know, we've known for about 100 years now that the corona is incredibly hot. It is millions of degrees hot, even though the solar surface is only a few thousand degrees. And we're still trying to understand exactly how the corona's magnetic field carries that energy up from the solar surface into the corona to heat it to those high levels. Our observations today will open new discovery space with wavelengths that are very rarely observed, that will allow us to apply physics models to better understand how that corona is heated. We'll also be looking at the structures of prominences or material from lower down that's kind of suspended in the
Ora sì, ora si vede. Vivo.
Dime.
¿Qué tal? ¿Cómo estamos? Ah, sí, hombre.
Sí, lo bueno que tienes es que puedes mirar por debajo.
Que ya.
Vaya, porque no me sorprende.
Ya va rápido, ¿eh? Más rápido. Sorprende que haya. Pero ahora ya estamos en el eclipse. Ahora ya no. Vamos a esperar un poco más.
Sí, empieza un poco, mira, por la parte derecha inferior.
Es cierto.
¿No?
Así es, justo por ahí.
Sí, ya empieza con el poco, ¿eh?
Sí.
No fastidies. Tú llevas ya media hora, ¿no? Tú llevas ya media hora, ¿no?
Me quedo ahora todo mirando y no veo. Me quedo
Claro.
A ver luego para bajar.
No, para bajar. Me intentaba meter miedo de categoría. Hombre. La foto de categoría,
El día especial.
El día especial, además. Sí.
Claro, digo yo.
Es raro. Habrá algo problema. Tienes que tener pine que al tenemos.
Cuando esté completa hay que quitar.
¿Qué dices? ¿Cómo va a ser una hora? ¿Qué? ¿Una hora? Pues te das cuenta tú también, ¿no? Hemos hecho...
Tenemos la del restaurante.
Dile que no está como la menos. Ángel, vete para acá.
C'est pas une mauvaise idée. Très chouette. C'est une multiplication artisanale
¿A que no te atreves? Claro, si me quiero cortar la de la huella.
Pero si tienen todos,
Bon, bah écoute, pour l'instant, les nuages ne sont pas proches. Attends, on a un pot pas possible, ça. Voilà. Il n'y a pas un seul nuage. Oui, il y a la brune qui nous donne un petit peu. Alors maintenant, préparez-vous, c'est pas encore, au moment de la totalité, vous allez voir, c'est autre chose. La couronne. Oui, moi ce que j'aime beaucoup, c'est regarder l'horizon. Ah oui. Tu regardes, tu as des étoiles noires. Ah oui, d'accord. Le ciel est noir. La couronne, je veux bien. Mais le ciel noir avec les étoiles et l'horizon clair. Ça, c'est un sentiment.
Ici, ça va être spectaculaire.
Ah ouais.
Ici, ça devrait être spectaculaire.
Ça devrait être spectaculaire. Donc préparez-vous à ça parce que ça va durer. Prépare-toi au moment de la totalité. Bon, la couronne, ok. Mais ce qui est intéressant, c'est normalement on doit voir les étoiles et l'horizon clair. Ça, c'est scotchant. On va essayer de reconnaître les étoiles qui sont au-dessus.
Allô?
Je vais demander à... J'ai envie de téléphoner à Alain pour voir s'il est en train de regarder. C'est bien, non? Ouais. Vous voulez que je me mette en face pour vous montrer? Je pointe du doigt si vous voulez. Regarde. Là, je vois bien, là. Oui. Vous l'avez là? C'est bon? Ouais. Voilà. Petit montage artisanal. Il faut savoir faire de la physique avec des appareils compliqués, mais aussi avec des montages simples. Et donc, préparez-vous, si vous n'avez jamais vu d'éclipse, préparez-vous au moment de la totalité à voir les étoiles dans le ciel. Et l'horizon, lui, est lumineux. Ça, pour moi, c'est la chose la plus extraordinaire pendant une éclipse. Je garde mon chapeau. Il a l'air ridicule, mais ça ne fait rien. Donc là, vous m'expliquiez que un petit peu juste un peu en arrière. Parfait. Donc est-ce que vous nous présentez s'il vous plaît? On regarde. Je suis Alain Aspect, je suis physicien, je suis essentiellement connu pour mes travaux en physique quantique, mais ici je suis là pour observer ce magnifique phénomène de l'éclipse. Alors c'est ma troisième éclipse dans ma vie, la première j'avais 15 ans, la deuxième c'est il y a 20 ans, C'est ma 3e éclipse dans ma vie. Ce qui me semble le plus extraordinaire pendant l'éclipse, c'est au moment de la totalité. Le ciel est tout noir, on voit les étoiles, par contre l'horizon, lui, est lumineux. Et je trouve que ça donne un sentiment extraordinaire. Alors ensuite, ce qui m'intéresse là-dedans, c'est d'expliquer que on peut parfaitement prédire le moment des éclipses parce qu'on sait parfaitement décrire le mouvement de la Terre autour du Soleil, de la Lune autour de la Terre, etc. Et ça, on sait le faire depuis l'année 1600 avec les travaux de Tycho Brahe, Copernic, Galilée.
Et donc vous espérez voir ce phénomène? Vous êtes sûr de voir ce phénomène ce soir?
Sauf s'il y a... Oui, absolument. Parce que l'obscurité, on est certain de la voir. Qu'il y ait des nuages ou qu'il n'y ait pas de nuages, on aura l'obscurité. Si le ciel est clair au-dessus de nous, on verra les étoiles. Et j'espère qu'on verra l'horizon très clair en même temps. Voilà.
Merci beaucoup.
Avec plaisir.
muy al hilo esto, díselo a Carla, por favor. Va muy al hilo con lo que está contando esta chica. Vale, Carla, viene muy al hilo en lo que está hablando esta, lo que yo tengo aquí.
Try to be stable. Try to be stable. You're moving a lot. Okay. Okay, so for each shot, so okay, so if you give me 20 seconds for each shot, I can try and coordinate this. Like you do like 20 seconds before you move, you know? Okay. Don't worry, don't worry. Hey. Hello? 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 I think it's fixed now. Can you just double check? No, non è tu, non è tu, non è tu, è lui, qui ce l'ha già. Va bene, Federico ci ha detto, adesso metti che ci puoi vedere la totalità, quindi dopo devi lavorare, c'è un po' d'ansia. Grazie.